We hear the word average all the time, right? Average salary, average temperature. But what does that one number really tell us? Sometimes it's the whole story, but other times, well, it can be super misleading. So in this explainer, we're going to dig into that. We're going to figure out how to find the true typical value in any set of numbers. Let's dive in.
All right, to get our heads around this, let's use a super simple example, something we can all relate to. Let's say you're a teacher. You've just graded a stack of 10 tests. You're not looking at individual students just yet. You just want to know, how did the class do overall? What was the typical score?
Okay, so here are the scores. 10 students out of 100. And at a glance, they look pretty solid, right? Lots of 80s, a few 90s. The class did well. So, if we want to find that one typical number, what's our first instinct? It's probably to find the average, right? And the way most of us think about average is what's officially called the mean.
Yeah, the mean. This is probably what you learned in math class. It's simple. You just add up all the values and then you divide by the number of values you have. It's a really popular method because, well, it's easy, and it uses every single piece of data you've got. Nothing gets left out.
All right, let's do it for our test scores. First step, we add up all 10 scores, and that gives us a grand total of 866. Next, we divide that by the number of students, which is 10.
And there we have it, a mean score of 86.6. And you know what? That feels about right. It slots right in there with all those other high scores. Looks like a really good, really fair summary of how the class performed. But what happens when life gets a little messy, when the data isn't quite so perfect?
Okay, let's throw a wrench in the works. We're going to change just one number. Let's say one student just had a really, really bad day. Maybe they didn't study. Who knows? Instead of a 78, they get a 20. Ouch. Everyone else's score is exactly the same. In statistics, we call a value like this, one that's way off from the others, an outlier. Let's see what this one little outlier does to our so-called typical score.
So we run the numbers again, and whoa, the mean just dropped from 86.6 all the way down to 80.8. Just think about that for a second. That one single score of 20 yanked the entire class average down by almost 6 full points. And this, right here, is the mean's kryptonite. It's super sensitive to extreme values.
This is where we have to stop and put on our analyst hats. I mean, really think about it. Does 80.8 feel typical for this class? Look at the scores. 9 of the 10 students scored an 82 or higher, and yet our average is now below that. It just doesn't feel right. It doesn't feel honest. Clearly, the mean isn't the right tool for this job. We need something else.
So if the mean let us down, what are our options? Well, luckily, we've got a couple of other tools in the shed. It's time to meet the median and the mode. Let's start with the median. Now, the median plays a totally different game than the mean. See, the mean cares about the actual value of every single number. The median, it only cares about position. You just line up all your numbers from smallest to largest, and you find the one that's sitting right in the center. And that's a superpower. It is not affected by those crazy high or low numbers. It's basically outlier proof. So how do we actually find it? It's a simple two-step deal. First, you gotta sort your data. Put all the scores in order, from lowest to highest. Then, you just find the number in the dead center. Now in our case, we have 10 scores, an even number. So there isn't one single middle number. No big deal. We just take the 2 in the middle and find their average. All right, let's do it with our test scores. Here they are, all lined up nice and neat, from low to high. And check it out, see that 20? Our outlier? It's just sitting there on the far end. It's been neutralized. It can't pull everything down anymore because we're focused on the middle. So our 2 middle numbers here are 86 and 88. Okay, so we take the average of 86 and 88, which gives us a median of 87. Now that feels right, doesn't it? 87. That number really captures the spirit of this class, where most kids were scoring in the high 80s. The outlier is still part of the data. We haven't ignored it, but it's not running the show anymore. And that brings us to our third and final measure, the mode. The mode is honestly the easiest one to understand. It's just the number that appears the most often. And it has a really cool, unique trick up its sleeve. It's the only one of these 3 that works for stuff that isn't numbers. For example, you can't calculate the mean favorite color, right? But you can definitely find the mode, the most popular color. So, if we look back at our list of scores, the number 85 shows up 2 times.
Everything else just shows up once. So simple as that, our mode is 85, another score that feels pretty typical for this group. Okay, the moment of truth. We've calculated all 3 of our measures for our dataset, the one with the outlier. It's time for the showdown. Mean versus median versus mode. Which one is telling the most accurate story?
And wow, when you see it like this on a chart, it's just so obvious. Look at the mean, way down there at 80.8. You can literally see how that one low score dragged it away from the pack. Meanwhile, the median and the mode are right there together, hanging out where most of the scores actually are. They're telling a much more consistent story. So, what's the verdict? For this particular set of data, the median, at 87, gives us a way more honest picture of a typical student. And there's a technical term for this quality. We call it being robust. A robust statistic is one that can stand up to outliers, one that doesn't get pushed around easily. And the median? It's pretty much the definition of robust. And you know, this goes beyond just a simple math exercise. The choice between using the mean or the median really says a lot about what you think is a fair and balanced way to look at the data. Think about it. If we had just reported the mean, we would have basically punished the whole class performance-wise, all because of one student's really bad day.
Okay, so the big question is, how do you know which one to use? When should you pull out the mean, and when is it time for the median? Well, it all comes down to 2 things: the shape of your data and the story you're trying to tell.
Think of this as your quick and dirty guide. The mean is awesome when your data is nice and symmetrical, like a perfect bell curve, with no wild outliers. But the second your data gets skewed by outliers, the median becomes your hero. Now, it's not perfect. Its weakness is that sometimes those extreme values are actually important. If that score of 20 was a sign of a real problem, the median might hide it. And the mode? That's your guy for categorical data.
And this explains so much about what you see in the real world. Ever wonder why news reports always talk about the median home price or the median salary? It's because of outliers. A handful of billionaires would make the mean salary look ridiculously high. But for something like the average daily temperature, which is usually pretty balanced, yeah, the mean works great there.
So if there's one thing you walk away with, let it be this: there's no single best average. It's not about one being good and the others being bad. A smart analyst knows how to use all 3. It's about looking at your data, understanding the context, and picking the right tool to tell the most honest story possible. So, I'm going to leave you with a little challenge. The next time you're reading the news and you see a headline about the average price of something, what's the very first question that should pop into your head? If you find yourself thinking, hold on, which average are they talking about? Is that the mean or the median? Then congratulations, you're officially thinking like an analyst. Thanks for joining this explainer.